Okay, so what we've been talking about is fairly interesting and fairly challenging, but I 100% absolutely need your undivided attention, because we're right now about to do something. I'm going to spend an unbelievable, this is one of the 2 times during the semester when I spend an unbelievable amount of time talking about the idea of what's going on, because this next idea I find is a relatively tricky leap, and it's very important to understand what we're about to do. So I'm going to spend a lot of time with me talking and making very few calculations, just so you understand the idea of what's going on. So this section and chapter is about what happens when you take a sample. So what happens when you take a sample? Well, in order to present the picture, I'm going to present you with some data. Now, for the purposes of this discussion, I'm going to assume that we have a very, 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 very small population. I'm going to assume that my population has 5 people in it. Now, this, of course, is a ridiculous assumption. You would never say, okay, I want to study a grand total of 5 people and then take a sample from that. I'm going to do that so that the numbers that we're dealing with are small. Okay. So just keep in mind that the entire population has 5 people in it. And later on, as you see, we're going to take samples of size 2, which is, of course, ridiculous in practice, but I'm doing it so we can work with the numbers. So here we go. So let's, okay. Can you all see these numbers? Let's see. I should be able to blow it up a little bit more. Okay. Can you guys see these numbers? Okay, good. Okay, so here is, I'll shrink that down. Okay, so here's the entire population. I asked 5 people, my entire population is 5 people, and here are the ages. Their ages are 29, 22, 25, 24, and 23. Thank you. Okay. So, again, how big is my entire population? My entire population is 5 people. Now, let's do some calculations on this population. So, what's one thing that you can calculate? You can calculate the mean. Now, we're calculating the mean for the population. What is the notation for that? I heard it. It's the mu. Mu represents the mean for the population. Alright. So add these numbers up, divide by 5. You get 24.6. Okay. Now what is something else that we can calculate? Standard deviation, absolutely. Now we're finding the standard deviation for the population. What is the notation for that? Sigma. So it turns out that if you calculate that, the standard deviation for this population, you get 2.70185. Something. And remember that is, that's sigma. Okay. So right off the bat, we can write down some things about the population. Okay. Capital N. What is capital N? What does that represent? Yeah. N is the number, which just means the size of the population. So what is that? That's 5. And what's mu? It's the mean. It's 24.6. And what is sigma? It's the standard deviation. It's 2.70185, blah, blah, blah. Alright. Now I want to write something else down, which we're going to use in a minute, because it's easy to calculate and understand. What is the range for this population? Right. Biggest data value 29, smallest data value 22. The range is 7. Okay. I think so far that that's clear. Now, what would happen if we were to take a sample of size 2? And again, remember why we take a sample. We say I've got a population, but I can't ask everybody, so I have to take a sample. So let's take a sample of size 2. What is one possible sample? 22 and 29 is one possible sample. What is another possible sample? 29 and 25. What is another possible sample? 29 and 24, etc., etc., etc. So what I'm telling you right now, which we'll actually know how to figure out by the end of the semester, but what I'm telling you is that there are 10 possible samples, and what I'm going to do right now is I'm going to actually write out every single one. Here they are. (29, 22, 29, 25, 29, 24, etc., etc., etc.) This is every single possible sample that you could have. So, first of all, let's pretend we're in universe 1 where we take sample 1 and we said, oh, I want to find out something about my population, so I'm going to take a sample. Take a sample size 2. The first person says my age is 29. The second person says my age is 22. If we're doing this as a study, what is something that we would calculate? We would calculate the mean. Now this seems a little silly. Again, my population is size 5, my sample is size 2. But again, use your imagination. Pretend we're in a more realistic setting. So I would calculate the mean. So for 22 and 29, how do I find the mean?
29 and 22.
Add them up, divide by 2. For sample number 1. So if you do that and you calculate the mean, you get 25.5. Now, suppose a different person takes a sample. They get sample number 2. First person says 29, second person says 25. What would they then calculate? They would calculate the mean. And what would that person's mean be? 25, 29, the mean is 27. So person number 1 doing the study, getting sample number 1, their mean is 25.5. Person number 2, they get sample number 2, and their mean is 27. Now, when I say you do a study and you get a sample and then you find the mean, that's the mean from a sample. What is the notation for that? Getting the mean from a sample. Yes, X bar. So there are 10 possible different samples that you could get. Each sample has its own mean. Each sample has its own X bar. And that's what I'm going to write down right now. Here we go. Sorry? Okay, So what's highlighted in gray is the X bar for each sample. So I just wanted to emphasize 25.5, that's an X bar from sample 1. 27, that's the X bar from sample 2. 26.5, that's the X bar for sample 3. 26 is the X bar for sample 4, etc., etc., etc.
So if you find the average of the samples, will you find the mean of the population?
Awesome question. That's an awesome question. And that's one of the things that we're going to talk about right now. Oshrit asked if you take the average, I think you're asking about the average of all the X bars. What does that give you? Does it give you the average from the population? So, first of all, what do you think? Does it? Well, there's only one way to find out. Do it. Where? 25.5, 27, 26.5, 26, 23.5, 23, 22.5, 24.5, 24, 23.5. You work out the average, and what do you get? 24.6. Sorry? Yeah, that's exactly right. Benny made a good point. This looks like a 10-number survey. So you're right in a sense. What we have when we take a sample, you could think of it this way, is we have a set of possible values for X bar. Now the question is, well, what does that have to do with our original population? Well, what we just found is that the mean is exactly the same.
Because you're using all the different combinations in the sample. So you're using your entire population, all the
Yes.
samples.
Yes, and you can actually prove it. We're not going to do that, but you could. All right. So what we found is that the mean, when you talk about your X bars, is going to be the same. What's the next thing we need to talk about? The standard deviation. So the question is the standard deviation going to be the same? What do you think? What do you think? I get some yeses and some nos. Okay, good. That means you're thinking about it. So, what does standard deviation measure? Think back to when we learned standard deviation. What does standard deviation measure?
The distance, the data, how many units.
No, that's the z-score. What is standard deviation as a number itself measures what? It measures how spread out your data is. So a bigger standard deviation means your data is more spread out. So the question is, if you look at the original population numbers, and then you look at the X bars, do they have the same spread? Or are they spread out in the same sort of way? Well, there's 5 population numbers, there's 10 X bars, so it might be kind of hard to figure out. But let me give you some insight into the answer to this question. What was another very simple way to measure how data is spread out? The range. What was the range for the population?
7.
It was 7. What is the range for the X bar data?
25.
Nope.
Well, the range stays the same. 29.
Yeah. Because in the x bar, well, all your x bar values put together, we know that that's called the distribution. So in the distribution of x bar, all that data, what's the biggest value? 27. Smallest value. So the range is 4.5. So that should immediately give you an intuition about the standard deviation. Is the standard deviation going to be the same? No. What's it going to be? It's going to be smaller. Because just by looking at the range, you can immediately see that the values from the distribution of x bar are going to be packed closer together than in your population.
And then remember the formula that we did was the formula for a sample involves minus and 1 from n to the effect curve. You know what I mean?
Not related. I mean, that's not the major point here. Okay. So does everyone, after talking about this, does everyone agree that if you look at all the x bar data, that the mean is going to be the same, but the standard deviation should be smaller? Does that make sense? Okay. So that brings us to the next bit of. So that's the idea. This idea has a name and a formula, but I want to make sure you understand the idea first and why the idea makes sense.